Hi there! In my last video I demonstrated this principle of using a relay with 3 poles. It's actually 4, but I only use 3 to be able to get a carriage to move, in this case from the left to the right, and then go back again on its own without having to do anything to it. So how did it work? Well, if I can find a button, I'll put a button on and press the button, and it goes across and comes back again. Has one big fault though: it doesn't stay when it gets to this end. It just goes across, hits the limit switch and goes straight back again. So it's hitting the switch and then going back. That isn't good for the motor because it's going one way and then suddenly the other way, so that ain't a good way to work. So what I want to do is put in a delay when the motor is out, and also get rid of the 3-pole and just use a 2-pole relay. Right, so if we have a look at this, what we've got, that was what we had before, with our changeover switch here, so the motor goes in the opposite direction, and a 3rd pole so that the relay latches when it moves across. The blue goes to the 0 volts, the green goes to positive, and this black connects to here at the bottom of the relay, giving us a circuit so that it can flow through this way, and holds the relay on, latches the relay on, until this out switch opens when the relay goes off and goes back to this position, so the motor goes in the opposite direction, and then opens the in switch and then it stops. But this is a bit tedious, and 3-pole relays aren't an ideal system. So if we have a look at our circuit without the 3rd pole on, just the changeover, we can see that the relay wants to go to 0 volts. Well, this is 0 volts. So if I connect from the bottom of the relay to the bottom of the blue switch, then when the relay is energized, the blue wire goes across to the negative here. I press this button. Let's draw a line in, shall we? It's going to go, what a brilliant pencil. Let's go across here. And no, wrong, I've done it wrong, haven't I, again? Keep managing to do this wrong. I find this very difficult to follow. Let's try again. Let's put a connection across there. So now I've connected my blue, bottom of my relay, to my blue, so that when my blue comes across here and touches 0 volts, we have a circuit for the relay. This is one sort of small problem, and that is when I push this switch, this is connected to 0 volts, but this connects through the relay to positive. So we have a short circuit. Not good. So how can we get it so that the current can flow through the coil, round here, through the blue, and then back round this way, but not from the red through the contact here and go that way? Well, to do that, I put in a diode. A diode is a one-way device. It lets the current flow that particular way. Well, not in this case because it's a positive, so no current would flow. But when the relay is energized and this moves across to here, then the current can flow down here through the blue wire, across, round, through, down to ground, and the relay latches on. The motor, of course, turns because one side's at positive and the other side is at negative. So therefore, we can do away with our 3rd terminal. Of course, this is no good as it is. We've got to put some limit switches in. So we just put the limit switches on the crossovers of the relay, so that now when this out switch opens, there's no circuit for the relay to latch on, so it goes off until it gets in. When it gets in, it opens this contact and then it stops. So yeah, that's the way to do it. A way to get a 2-pole relay to latch on. Brilliant, but we still have the problem of when the motor is out, it comes straight out and then tries to go straight back in. We want to be able to overcome that somehow. So how can we overcome that particular problem? Well, if we use one of these, this is a capacitor. It stores energy or electricity and is 3,300 microfarads. That's pretty big for a capacitor. It's only 10 volts, but that's perfectly adequate for what I want. But where am I going to get one from? Well, these come out of old computer power supplies. Got to be careful with power supplies because some of the capacitors aren't 10 volts, they're 400 volts. And a 400 volt capacitor can hold an awful lot of energy. So we need to be very, very careful to make sure that they don't discharge through us. So we've got to discharge them first. A screwdriver or something across the end can produce quite a big flash at times. So what can we do with our capacitor? Well, let's show how it works. If we can get it the right way around, put positive into positive and negative into negative, and nothing's happened. Hopefully I've charged it up. So I want to see now if it is charged, and to do that I'm going to use an LED with a resistor on it, and if I just put that the correct way around, so the resistor's the positive, put it across, and hopefully if I can get this right, oops, there, not quite right, try it that way. Hopefully we saw that the LED lit up. Not for a long time, just for a short time, but that's all we want with our capacitor to do, just to stop the motor for a short period of time. So let's have a look at the circuit. Well, I've actually built this onto a little model here. I built it on strip board, Veraboard as I think it's called commercially, because I only wanted to build one. It didn't seem worthwhile building a lot of them. Will it work? Well, let's try it. What we have is the usual, a rack along the bottom and a pinion that moves over the rack. So if we try to get this to work, switch it on, there it is on, press the start button, and there it goes. The rack, the pinion is driving across the rack until it reaches the out switch. It only stopped for about a second or a second and a half, but it was long enough for the motor to stop and then turn and go in the opposite direction. I've got a limit switch at the outside, of course, and a limit switch here on the inside, so those are how it actually works. If we look at, switch it off, look at the circuit board, then what we've got is actually two 3,300 microfarad capacitors which are driving this 5-volt relay. It's not a very complicated circuit, very similar to what we've looked at before. Where are we? So what we have then is our coil, broken pencil, our coil here with a diode across it to prevent reverse EMF. When the magnetic field round the coil collapses, when you switch off the current, there's a magnetic field round it. It collapses and it produces quite a high voltage, which could damage some components. So we put a diode across so that it takes the high voltage round and doesn't damage anything. We have here a resistor, so that the capacitor, when the button's charged, it doesn't charge the capacitor instantaneously, which may damage it. So it charges it reasonably slowly, and then the capacitor charges. When we press the button as well, because it's in parallel with the relay, current comes down through here and through the start, and so the relay energizes. When the relay energizes, then the blue goes to the 0 volts and the green goes to the positive. That then allows the motor to drive. In this particular case, I've got a couple of diodes across the limit switches, because then I can get away with 3 wires going from the model to the circuit board. But as most of my circuit boards now are on the models, then I don't need the limit switches out here, and I can put them on the changeover contacts on the back of the relay, connect them to those. So the current then flows through the relay, through the yellow diode, down here through the switch, and then, because this is energized, across to the 0 volt and round, and so it latches the relay on. So here we have our relay latched on. The blue contact is at 0 volts and the green is at positive. So when the trolley gets out, it opens this normally closed switch, and therefore the current can't flow through the relay, through the diode, and through the here to get to 0 volts. So the relay isn't energized due to this circuit. But what we have got is our large capacitor and resistor, 6,600, because I've got two 3,300s, and that then goes through the relay and holds the relay on for about a second or something like that. Once the relay has gone, once this is discharged, the relay goes off, and then this goes over until the switch comes in when it switches off. This isn't a very long delay, and maybe I want a longer delay. To get a longer delay, then I'm going to put in a thing called a transistor. Never mind. So the transistor allows a large current to flow through the relay, 80 milliamps in this particular case, just for a 0.8 milliamps on the base of the transistor. But how are we going to wire this so that we can have the relay, the transistor on for most of the time, but not on once the out switch opens? To do that, then, I've connected the blue goes through a diode D2, and the green goes through the diode D3. So as it is here, when the relay is energized, as it is here, the current flows through here, down through the green to the diode D3, goes through and switches the transistor on. Before we switch it on, difficult to see, the green connects to the 0 volts, but the blue connects to the positive. So therefore, when it's off, when the relay isn't energized, the transistor switched on by the current flowing through the blue D2, and then switches the transistor on and also charges my capacitor. So when I press start, the transistor's energized, it allows the current to flow through it. It flows through D4, flows through here, round this way, and therefore the relay energizes, and it stays in this position until the out switch opens. When the out switch opens, then the D2 is reverse bias because it's on 0 volts. The green isn't connected to positive anymore, so it doesn't supply a current, and so therefore the capacitor starts the discharge going through the transistor and round through here. this way, and eventually when the capacitor's discharged enough, then the transistor switches off, so the relay is no longer energized, and the switch goes back and it comes in. So, and then once the carriage is in, it opens the in and switches it off. So let's have a look at that then. So where is it? Have we got this gizmo? Well, here's the circuit I've built. Which way round? That way round, perhaps easiest. So what I have is my two connectors for my limit switches, my motor circuit, my relay with a LED across so we can see what's happening, the feedback resistor and the two feedback diode and the two charge diodes there, and then we have a resistor here for the LED to show the power's on, and the resistor here which comes down to charge the capacitor. Okay, we have our transistor in here, our start button here. So will it work? Well, let's try it. Must get these, always get them the right way round. Wrong way round and the motor drives it and it gets to a stop it doesn't expect, so it doesn't stop and therefore destroys the model. So we've got out, we need out there. Where's out? So that's out, and this one is in, hopefully. So there we have out, 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 in, and motor. We need to connect the power, so I'll get that the right way around. LED comes on, so it's already switched on. And what I need is a start button. Oh, I can't find a start button, so I'll be crude and just short it using a screwdriver. And if I short it, goes across, waits for about 4 seconds and comes back again. I can adjust the time, I can get quite a long time on this, about 20 seconds. But there it is, going backwards and forwards. Could play with that all day. Keep thinking it's not going to work, but eventually it does seem to. So that's using transistors to develop the board. I did design a surface mounted board for this using surface mounted components with a tiny little transistor on it. Just there's my tiny transistor. These are the diodes, but I wasn't really happy with this transistor technique, so what I did was to move on and use a 555 timer. So in my next video we'll look at the 555 timer use instead of all these diodes and transistor. So it's been quite a long journey, but got there in the end, and I do love to play with these things. It's very bad really, but I'll put a button on. No, I won't. Yes, I will. Put the button on and press it, and I can carry on all night just watching this go backwards and forwards. So it's bye now. Bye.